Yesterday in your lab, you looked at how pressure changed when you changed the volume. Today we're going to discuss the law that looks into this relationship. The law is called Boyle's law. So Boyle's law states that the relationship between pressure and volume is an inverse relationship. And hopefully you figured that out yesterday when you recorded the data points and got a graph. Your graph looks something like this. So what I'd like you to do right now, you have your flip book for the different laws. I want you to put in that flip book, we had that top part under your Boyle's law, put inverse relationship and draw a graph like that. So the graph is showing you that as volume increases, pressure goes down. So that's your inverse relationship. So a review about what inverse is. So if we had the number 2, what would the inverse be? It would be 1 over 2. So the inverse is always, in a fraction form, would be 1 over the number that you originally have. So 1/2 is the inverse of 2. So when we look at pressure and volume, and we say volume is the inverse of pressure, we have volume underneath pressure. And so this is the discussion a formula showing the relationship that volume is inverse of pressure and that those would equal a constant. We will look at that constant when we talk about ideal gas law, but this is just one way to show the relationship between pressure and volume. What we're going to use is an equation that helps you figure out what happens when you change either pressure or volume. What's going to happen to the other variable. So the Boyle's law is used to look at what happens to either pressure when we change volume, or we can use it to look to see what happens when volume gets changed by changing pressure. So in these equations, we're going to have an initial pressure and we'll have an initial volume. So those are what we start out with. And then we're changing one of those variables, and then we're going to figure out what the final ones will be, the final volume or pressure, depending on what the question asks. So let's look at some problems. If you have your worksheet packet out, we're going to be on page 2, worksheet 2, pressure and volume. If you need to pause so you can go get it, and then we'll start right back up. Okay, so when we are doing these equations, there are 4 variables within the equations. We have our initial pressure, we have our final pressure, we have our initial volume, and our final volume. And we use number 1 to indicate the initial and 2 to indicate the final. So our equation is P1 times V1 equals P2 times V2. So before we start problems, write this equation in your flip book. So you would have your flip book down on the bottom under the flap, and just write P1 times V1 equals P2 times V2. In your worksheets, you'll see that you have a table like this. This table is useful for solving all our gas law problems. We're not going to use 2 of the variables in this problem. So the first thing we're going to do is just cross off those variables because we're only looking at pressure and volume. Okay, so the next thing we're going to do is try to determine what are the initial pressure and volumes, and then what's the final. So looking at our question, we can see that the initial is all in that first sentence. So it's saying that we have a gas at 5.4 atmospheres and a volume of 1.3 liters. So at 1.3 liters, the gas is 5.4. So those go together. So there's our initial pressure, our initial volume. So put it right in the table. So now we're going to look and figure out what the final values are. We have the question, what volume would the gas have at 6.8 atmosphere? So volume is our unknown. And we have that the final pressure is 6.8. So there, I moved that x up to the final. X is our unknown, and it's asking us what volume is, that's why we put the X, but it tells us our final pressure is 6.8 atmospheres. So now we're going to plug this into the equation. So remember, our equation is P1 times V1 equals P2 times V2. So our P1s, our initials, our 1s are right in that row. So we have 5.4 times 1.3. Make sure you use your units. And then our final would be in the final. This is got shifted down. Sorry about that. So the final would be 6.8 ATM times V2. I put the V2 in there. I like seeing what I'm solving for. If you had an X down there, it would be okay. So our equation, solve for it. Our P1 times V1 equals P2 times V2. And we're solving for V2, so we're going to divide both sides by 6.8 so that V2 is alone on the side of the equation. And we can see that we can cross off the atmospheres, so we will be left with liters in our final answer. And if you do the math, 5.4 times 1.3 divided by 6.8, we get 1.03 liters, and that is our final volume. So you could put that in the table. So put that in the table, and then on your table where it talks about effect, so here we go, your effect, you're going to look and see, okay, did pressure increase when we changed? And that it increased, so you would put increase, or you could put an arrow going up, and then look at the volume and see, did the volume increase or decrease? And remember, our new volume was 1.03, so that decreased. So put an arrow going down. Alright, so try the next 3 problems. If you have any questions, be sure to ask. Thanks.